So today what I want to talk to you about is measurement in science and the quantities that we're going to measure in physics. All right. You've talked about some of these in other classes, okay? But it's called the System International SI base units, okay? And what we measure length in, and these are, I'm going to highlight the ones that are going to be used mostly in physics, okay? And especially this first semester, okay? So length. How we normally measure length is in meters, okay? Mass is going to be important for us, and we usually measure it in kilograms, okay? Time is going to be a quantity that we measure, and the unit is seconds. That's the base unit, okay? There are other time units, yes, but the one we use most often in physics is seconds, okay? And then if we get to it, it'll be towards the end of the year, electric current, and that will be ampere, okay? Or amps, guitar amp, that's where it comes from, okay? All right, so these are the base units, okay? Temperature, you learned about Kelvin in chemistry last year. Amount of a substance is mole. These are the base units, okay? And then if we start combining these, we get a thing called derived units, okay? And that's gonna happen later on, like miles per hour. Well, miles is a length, okay, over a time unit, which is hours. That's a derived unit. And we could convert miles per hour to meters per second, which would be the standard base units that we use in this system international. And it's just something that we've all agreed upon, okay? It's man-made. It's just agreed upon. These are the units that we're going to use, okay? Another one that you guys are used to is a derived unit would be meters cubed, because meter it's not one of these, right? But you can get meters. Volume is meters times meters, or meters cubed. And then if you put a mass divided by meters cubed, you get density, because it would be mass over volume. And you learned about that a lot over the last years in seventh grade science and eighth grade science, and even in chemistry, okay? All right, so let's go to the next thing, which is metric prefixes. Let me talk a little bit about that. So, okay, what this is metric units. These up here, and I'm going to teach you how to read this chart in just a little bit, okay? These are for quantities that are really big. Like you would use a lot of these in like astronomy, okay? Distance to planets and distance to the next galaxy. You would use these prefixes, okay? And you're going to see you're going to see these prefixes, okay? Prefixes are the part of the word that comes before, and they actually mean something, okay? And then you're going to see these terms, okay, or some of these terms, or some of the derived units that we're going to come up with, okay? You're going to see these in the example names, okay? So this is called exa, peta, tera, giga, mega, kilo, hecto, and deca, okay? Now, kilobyte, megabyte, gigabyte, terabyte, that's how much memory computers have. When I was in high school, it was kilobytes. Then when I first started teaching, it was megabytes. Then I went to get gigabytes. Now it's at terabytes. Pretty soon it's going to be at petabytes, okay? Because that's the next evolution. They're going to call it a petabyte, not a terabyte, okay? When they have that much memory. Okay, some of these you might recognize: deci, like decimeter, centimeter, okay, millimeter, micro. And the symbol for this is a Greek letter. It's called mu, okay? Don't worry, I'm never going to test you on that, okay? But you have to realize that means micro, okay? And then nano and pico and femto and atto, okay? So what I want to show you, this is going to be a lot like dimensional analysis, okay? I'm going to tell you that right now. But look at the prefix, and then you see this word meter, right? So meter, second, watt, hertz, liter. Now, watt, hertz, and liter are derived units. Second, that's a base unit. Ampere, hectoampere, right? Decasecond, that's a base unit. You know what? I forgot to put one on here. Let's make one up, okay? Decimeter. Okay, so decimeter. So deci and then meter, right? Centijoule. Joule's a derived unit for energy, okay? Second, Newton. Newton is the unit that we're going to use for force. Like when you feel a push, that's a Newton, okay? So this would be called a micronewton, okay? Liter, that's a derived unit. Picogram, okay? And femtoliter and attojoule, okay? And joules, again, is energy, okay? All right, so like this is how you read this, okay? If you have one of these, then this is how many base units you have. So like this would be 10 to the 18th grams, or in this case, 10, if you have one hexameter, that'd be 10 to the 18th meters. If you have one petasecond, that'd be 10 to the 15th seconds. So this is telling you how many of the base units you have. So one of these is equal to like 10 to the 15th petasecond. So let me write that. So one petasecond and it doesn't matter what that is, I'm underlining second, okay, is equal to, and we're going to write this in scientific notation, okay, 1 times 10 to the 15th, 1 times 10 to the 15th seconds. Okay, now this is what's really important to listen to. It really doesn't matter if these are seconds or meters or grams or newtons. 1 peta of whatever is always going to equal 1 times 10 to the 15th of this base unit, okay? And right here is where the base units would go, okay? So that would be something like grams. That's a base unit. So you can say decagram, hectogram, kilogram, megagram, gigagram, teragram, okay? You could have something like seconds, exasecond, petasecond, terasecond, gigasecond, megasecond, kilosecond, hectosecond, decasecond, and so on, okay? You could have a volume unit like liters. It could be something like newtons, okay? So this is the factor that you have the more of, okay? So let's do another one of these, okay? So let's say I have 1 femto of something, and it really doesn't matter what, femto of something, that's going to equal 1 times 10 to the negative 15th of the same something. So 1 femtogram is equal to 1 times 10 to the negative 15th grams. Okay, so that's what's always going to be true, okay? So 1 milliliter so there's my base, right? 1 milliliter, or root, I guess that you could call the root. 1 milliliter is equal to 1 times 10 to the negative 3. So 1 times 10 to the negative 3 liters. Okay, so this is a conversion that we can use, right? Let's do one more. 1 hectoampere, 1 hectoampere. Okay, so what does hecto mean? 1 hecto means 1 times 10 to the second amperes. Okay? All right, so that's how you do this, okay? And then we're just gonna use this. Okay, so let me tell you this right now. I do not expect you to have this memorized. Some of these you may already know, like kilo, okay, and deci and centa and milla, okay? But that's okay. I'm not gonna, you can use this on a test, all right? I will actually print a brand new one for you to use on a test, okay? Okay, so here's the first example, okay? A typical bacterium, okay? Now, bacterium is singular, so it's one of them, right? We usually say bacteria because there's a lot of them, okay? Has a mass of 2.0 Fg, okay? Now, 2.0 Fg, Fg means femto, okay? So this means we have 2.0 femto and G stands for grams. So this is 2.0 Fg, that's what's given to us, right? That's what's, I'm gonna write given. And what we wanna find is this in grams, okay? So going back to this, okay, we know that 1 femtogram is equal to 1 times 10 to the negative 15th grams, okay? So we know 1 Fg, right, femtogram, all right, is equal to 1 times 10 to the negative 15th, and I'm just getting that off the chart, grams, okay? And so this is just dimensional analysis. So we're going to start with this one, and we're going to get to this one, right? So let's start with 2.0 femtograms, and then we're going to multiply that by a fraction, right? And the fraction we want is, we want to cancel out the femtograms. So 1 Fg, okay, over 1 times 10 to the negative 15th. Grams, okay? I'm going to grab my pen, and this femtogram cancels with this femtogram, and we would be left with 2.0 times 1, which would be 2.0, times 10 to the negative 15th grams, okay? All right, and that's exact, okay? So now what we want to do is take that and convert it to kilograms, okay? So the next thing we know, okay, is we got to use a conversion, because now we're at the base unit of grams. So we know 1 kilogram, right? 1 kilogram is equal to 1 times 10 to the third grams, okay? So we're going to need to use that. Now we're going to use this one. 1 kilogram, kg, you can use kg, is equal to 1 times 10 to the third grams, so G. Okay, so now we're going to start with this, and we're going to get it to kilograms. So 2.0 times 10 to the negative 15th grams times, okay, and then this would be right here, okay, so we'd want this grams to be in the denominator, so 1 times 10 to the third grams, and 1 kilogram. Now this is going to be a small number, okay? So then this, and you know it's a small number when it's a negative exponent on the 10, okay? That's a number that's smaller than 0, okay? If the exponent is bigger than, if it's a positive number, then you know that's going to be a big number, okay? That's more than 1, okay? All right, so here we go. So we know from this that this gram and this gram cancel, okay? And now what we have is 2.0 times 10 to the negative 15. So we're going to need to use some exponent rules here. So this would be 2.0 times 10 to the negative 15th over 1 times 10 to the third. And this would be kilograms. Okay, so what you could do is exponent rules. This is 10 to the negative 15th, and then minus 3. This makes 10 to the negative 18th. Because when you have an exponent like this, you're going to take this numerator, the exponent that's in the numerator, minus this one, as long as the bases are the same. And then you're just going to take 2.0 divided by 1. So this is going to come out to be equivalent to 2.0 times 10 to the negative 18th kilograms. And that's your answer to this. Okay? So for this next problem, we know a human hair is approximately 50, and here's that symbol, right? It's mu, okay? And that m is meters. So this is micrometers, okay? So let me write that, okay? And so I just know that because I've been doing math and science for a long time, okay? So I know from this, okay, I see that symbol right there, mu, right? It stands for micro. So this would be a micrometer, okay? So I know my base is meters, right? Okay, so what we know is that this human hair is 50 micrometers. That's been given to us. Okay, and what we want to get out of this is meters, right? Well, what do I know from my chart? So go back to my chart. I know that one micrometer is equal to 10 to the negative 6 meters. So 1 micro, I'm not using the symbols. Hold on a second. Okay, so I'm going to use my whiteout to get rid of this a little bit. Hopefully, there we go. Okay, so 1 micrometer is equal to, and I'm looking on the chart, okay, so 10 to the negative 6th, 1 times 10 to the negative 6th meters. Okay, so I'm going to start with this and get to meters, okay? So we're going to have 50 micrometers. And if you wrote micrometers, that'd be fine. Okay, like that's what I started to do here. I started to write the word micrometers. It's just this is the abbreviation of it. So you could use the abbreviation or you could actually write the word. Either way is fine, whichever is easier for you, okay? So, and then what I know is I need the micrometers to be on the bottom so they cancel. So 1 micrometer. And I can't write the mu very well, okay? And then over 1 times 10 to the negative 6th meters, right? Okay, and so then this would equal 50 times 1, which would be 50, times 10 to the negative 6th meters. Okay, so this is the answer. This is the answer that we got. Okay, however, in scientific notation, remember this has to be a number between 1 and 10 or 1 and 9.9. Okay, so that's not the case here, right? So we have to convert this. Okay, so that I don't want to say this is a wrong answer. It's just not written properly in scientific notation. Okay, so what you could do is write this as, okay, this could be 5 times 10 to the first. Okay, because 5 times 10 to the first is 10, so that's 50, and then times 10 to the negative 6 meters. Okay, and now because these bases are the same, I can add my exponents, so this becomes 5 times 10 to the negative 5th meters. Or you could also write this as 5.0 times 10 to the negative 5th meters. Actually, this is more accurate because, and it's something I'm going to talk about on Thursday. It's called significant figures, okay? This one's actually more accurate than this one, okay? But I would accept either one, okay? Okay, so here, the distance between the sun and Earth is about 1.5 times 10 to the 11th meters. Express this distance as an SI, so System International prefix, and in kilometers. So you actually get to pick whichever one you want, okay? So 10 to the 11th, I think is really close to 10 to the 9th. So I'm going to write this as a giga, okay? 10 to the 11th is also close to 10 to the 12th, so you could use tera. I would just do one that's close to 10 to the 11th, right? So I would choose one of these two, okay? So I'm going to choose giga, okay? So I know I have meters, and I'm going to want to switch it to giga, okay? So I know from my chart right here, okay, 1 gigameter, so let me write that, 1 gigameter is equivalent to 10 to the 9th meters, or 1 times 10 to the 9th. So 1 gigameter equals 1 times 10 to the 9th meters. All right, so we're going to start with this one. So 1.5 times 10 to the 11th meters times, okay, so I need this to be in the denominator, right? So 1 times 10 to the 9th meters, because then my meters cancel, right? I haven't been crossing those out, okay? And then I'd want 1 gigameter to be on top. So 1 gigameter, okay? So now, okay, this would be 1.5 times 1 over 1, which would be 1.5 times, okay, and this would be 10 to the 11th over 10 to the 9th. Okay, and I know Ms. Rami has been talking about exponent rules with you guys that are in Honors Math 3, okay? So right here, what can you do? You can subtract them, right? 10 to the 11th, okay, over 10 to the 9th is 10 to the 11 minus 9. So this becomes 1.5 times 10 to the 2nd gigameter. Okay, and that's how many gigameters there are between the sun and the earth. Okay, now let's switch it to kilometers. Okay, so I'm going to take this original one that was in meters. Okay, so I know I have to do this other conversion. I know that 1 kilometer, right, is equal to 10 to the 3rd meters. Okay, 1 kilometer. 1 kilometer is equal to 1 times 10 to the 3rd meters, okay? All right, so we're going to start with this 1.5 times 10 to the 11th, 1.5 times 10 to the 11th meters times, okay, so this time I want the 1 times 10 to the 3rd meters on the bottom. Why do I want that? Because then that will make my meters cancel, and I'll have 1 kilometer on top, okay? So this would be 1.5 times 1 over 1, so that's again 1.5. Now this time it's going to be 10 to the 11th over 10 to the 3rd. So times 10 to the 11th over 10 to the 3rd. And this, what we'd be left with is kilometers. So once again, my meters cancel here. And so the units that I have is kilometers, okay? And again, exponent rules, right? So what's 11 minus 3? 11 minus 3 is 8. So this becomes 1.5 times 10 to the 8th kilometers. And just remember, this number right here has to be some number, has to be 1 or bigger and less than 10, okay? So I'm going to say that right here. This number right here, okay, it needs to be, I'm just going to call that X. But it has to be less than 10, okay? All right, so you may have to move the decimal around to do that, okay? All right, guys, so this is a lot like what we've been doing. It's just you got to use the prefixes. Once again, I'm going to tell you, I will provide a chart like this for any test, okay? You do not have to have this memorized. I expect you to know how to use this. What happens is you start using this so much that you go, oh, a kilo is 10 to the third, is 1 times 10 to the third. Okay. You just start doing it. Okay. All right. Actually, I started doing that and I was like, no, I got to teach you guys. So I got to go grab it, right? To show you like, what would I do if I were you? Okay. All right. Okay. So one more thing that I'm not going to show you, but I know you're going to need this. Okay. For homework. We're going to do physics LE tonight. Okay. But you need to know some of these conversions. Okay. This is some of the conversions that we've been using on the Delta Math. Okay. But there's an additional one that I gave you that you may want to use. Okay. We have 1 hour is 60 minutes. Okay. In seconds, 1 hour is 3,600 seconds. You may need to use that on the homework. Okay. So I added that one. Okay. All right. So that's a new one that you may not have known. And again, anything on a test or quiz, I do not expect you to know all of these conversions. Okay. Some of them, yes. Okay. Like 1 week is 7 days. A lot of the time ones I would expect you to know, like 1 hour is 60 minutes, 1 minute is 60 seconds. 1 day is 24 hours, 1 week is 7 days. I wouldn't necessarily expect you to know that 1 month is 30 days because it's not always 30 days. That's just told to us so it makes it easier on us. Okay. And then 1 year is actually 365.25 days. Okay. All right. Actually, I think I have that. Oh, I have this one twice. Whoops. Okay. So you can ignore this one. It's just there twice. Right there and right there. Okay. Actually, I'll cross it out. Okay. All right. So that's it for today.